So let us start by giving an overview of the plan for the rest of this chapter. You should try it first actually. First, you should tell me what is the main topic of this unit. Yes, this chapter is about integration, but what did you learn about integration? And how have you organized the knowledge that you've learned? You know, as I often said, your insights come from your organization, so let us discuss one organizational strategy. At first glance, integration seems much more complicated than differentiation. But as we've mentioned in class, integration is in a sense just the inverse of differentiation. Or in other words, you perform integration by doing differentiation in reverse. Thus, the way we would organize everything we learn this chapter is by anchoring them to our previous knowledge of differentiation. Right, so now let's be a bit more concrete. In both units, you want to answer three main types of questions. The first one is, what's the main concept? Second, how do you compute it? And finally, why do you want to compute it? What for? What are the applications? Now the answers to those questions in these two units are going to be parallel in the following sense. What's the main object of study this chapter? Well, integral of course. There are indefinite integrals and definite integrals. As you recall, taking indefinite integral is in some sense the opposite operation of differentiating. The indefinite integral of a function gives you all of its antiderivative. And you can think of taking certain type of definite integrals as in a sense specifying a specific antiderivative, as opposed to giving all antiderivatives as in the case of indefinite integral. But a more common way to think about definite integral is in terms of sine area under curve, and we can define that formally via the Riemann sum. It doesn't really matter which viewpoint you want to start with, because all of them are going to be connected via the fundamental theorems of calculus. These theorems lie at the heart of integral calculus. It is what relates differentiation and integration. That will not only be our main tool of computation, but also our main source of intuition. Now, in addition to the fundamental theorem of calculus, we are gonna also discuss three other techniques which are obtained by basically reversing the three common rules of differentiation. And finally, for applications, we are gonna discuss how to use definite integrals to compute area under the curve and volumes of solids of revolution. But before I tell you how to use this to compute volume, it would be really good if you could try to figure it out on your own. Well, after we discuss the relationship between definite integral and area, of course. Alright, so that's the rough plan, and now let us start.